welcome everybody, and thank you all for joining us at this first virtual Intergeo. It's a shame that we all can't get together and meet in person, but yeah, times are a little bit difficult currently, so it's good that we can all connect in some kind of format. So my name is James Wardlow, and it's my pleasure to bring to you the Phase 1 PAS 280 megapixel aerial solution, and looking at what makes this a revolution in large format imaging systems by taking a brief look at the specifications, applications and examples. This is only a very short presentation of only around 10 minutes or so, but I will be available across the 3 days at the Phase 1 virtual booth to answer any questions or discuss the solutions and the specifications in greater detail. So first, of course, we'll be looking at specifications, and we'll be having a brief look at typical applications for these systems, and then at the end we'll have a look at some example imagery. So specifications. So looking at the Phase 1 aerial systems overall, so we have two main form factors of the aerial systems. We have the larger systems, which contain the multi-head cameras and the 4-band systems. These are housed in the SOMAG DSM 400, and then we have the smaller single camera solutions of 100 and 150 megapixel, which are contained in the SOMAG CSM 40. So the main topic for today is the larger system, the 280 megapixel large format aerial system. So again, this can be configured as either an RGB only camera with the 280 megapixel camera, or can be configured with a third camera with an achromatic sensor filtered for near infrared to provide a 4-band solution. This is all contained in the same SOMAG DSM 400 mount, so the system as it's presented is fairly modular. So if you only had a requirement at the start for an RGB camera, then the option is there to upgrade the system at a later date. The system also comes contained with the IX controller, which is on the Mark IV version now. This is basically the brain of the system. It houses the various software packages controlling the system, including IX Capture, IX Flight and IX Plan. And then sitting on top of this we have the various Applanix GNSS IMU solutions, supporting everything from the AVX210 right up to the POS AV610 systems. Of course, for these large format, large area coverage systems, it's highly recommended to go with the minimum of the POS AV510. So looking more into detail at the 280 specifications themselves. So on the table on the left is the table from our brochure, which is available for download through our channel here, but just to go through some of the key points. So the resolution is having more than 20,000 pixels across track. The sensor can support 2 frames per second of continuous capture, so no buffering involved there, so it is a sustainable 2 frames per second. And with this 2 frames per second, we can achieve a maximum of 97% forward overlap for 10 centimeter GSD at 150 knots, or we can have a maximal speed of 390 knots at 10 centimeter GSD with motion blur under 1 pixel. The sensor on the camera is the very latest in CMOS technology. It's the backside illuminated sensor. This is coming with a very wide dynamic range and light sensitivity ISO, which allows for improved light sensitivity for low flight conditions, and this allows for more flying hours per day, which equals more flights achievable per year. So how do we make this large format camera? So the camera is made from 2 separate 150 megapixel sensors. So these 2 cameras placed side by side. The imaging sensor has been adjusted in reference to the lensing system. So therefore what we actually achieve here is the right hand sensor is capturing the left hand side of the image, the left hand sensor is capturing the right side area of the image, and then there's approximately 5% overlap in the center, where we then, through our IX Capture software, taking into consideration the calibration information, tie point matching, we're then stitching the image together, which gives us a fully homogenic single 280 megapixel image, or actually 284 megapixel image, which is providing the, as mentioned, the most homogenic GSD across the footprint. We also have forward motion compensation, which is acquired through blur control technique. So the blur control technique eliminates the motion blur by short exposure time, which is enabled by using high-speed shutters up to 1/2000 of a second with the IXM RS280, and the higher sensitivity of 83 dB of the new generation of CMOS sensors. So when this is combined, it allows for shorter duration of the exposure time, or for the motion of the ground underneath across the sensor, and with the higher dynamic range of the CMOS sensors, allows us to formulate this method of forward motion compensation. So looking at two examples of this, so the example on the left with the little private jet, so this was flown from us in a Cessna 208. So we were actually flying from bottom to top, and then this little jet was just taking off from a small regional airport. So closing speed of the two aircraft together would have been somewhere around about 230, 240 knots. And as you can see in the zoomed in shot of the small citation type jet, there's absolutely no visible blurring whatsoever, despite the large convergence of the two flight speeds. And then on the right hand side, we have this helicopter that is in flight above the trees there. And again, with the blur control technique, we can see fully that despite the rapid motion of the helicopter's rotary blades, there is absolutely no visible blurring to be seen, and yeah, it's all down to the technology offered by both the shutter and the CMOS sensor. So now looking at various applications. So of course the big one here is mapping. So typical topographic mapping, urban planning developments. Yeah, the application of the 280 allows for larger area coverage with greater efficiency, and then this leads to obviously completing jobs in a much faster manner and with a higher degree of accuracy. When combined with the near-infrared camera, we also have the ability to do various environmental applications with the false colour infrared in sectors such as forestry, agriculture, and other various environmental research applications. So looking at an example, so this was captured by our colleagues in the US who recently flew their roadshow, where they were taking an aircraft with the 280 fitted around the United States. This was captured overhead Disneyland Florida. It was at 7.5 centimeter GSD, and this is just a small ortho over that area. And then we can see in the two zoomed in examples, we have the example of the Millennium Falcon from the new Star Wars display at Disneyland, and then also the main entranceway into Disneyland Paris with the famous Mickey Mouse flower display. So thank you for your time. Once again, my name is James Wardlow, and if you would like further information on the Phase 1 aerial systems, please feel free to jump into our booth at any time and ask for me personally, or if any of my colleagues are available, then they will be more than happy to help you. Once again, many thanks for taking your time to join, and hope you enjoy your stay at the virtual Intergeo. Thanks.